According to new leaks from Gigafactory Shanghai and early design blueprints that are believed to come directly from Tesla, the Model 2 will not simply be a smaller version of the Model 3. Instead, it is shaping up to be one of the most radical redesigns in Tesla's entire history, featuring what insiders describe as the most surprising exterior change the company has ever made. And remember, this is the car targeting a price under $15,000, the same one Elon Musk says will bring millions of everyday drivers into the world of electric vehicles. What exactly did Tesla change? Why are some early testers calling it the best-looking budget electric vehicle ever made? And could this new body design make Tesla's most affordable car feel like a luxury model? We are going to break all of it down in today's video. You are watching Auto Intel, where we talk Tesla the way real drivers do, no fluff, no hype, just real engineering and solid numbers. If you enjoy deep dives into the engineering behind the world's most advanced electric cars, go ahead and hit that subscribe button right now. It's quick, it's free, and it helps us keep bringing you the kind of content that actually matters to car lovers. Let's aim to reach 1,055 subscribers together and keep building a garage of knowledge for people who care about what's under the hood, not just the headlines. How can a two-door Tesla actually feel roomier? The 2026 Tesla Model 2 breaks tradition in more ways than one. For the first time in the company's lineup, a two-door hatchback joins the family. It is compact on the outside yet cleverly engineered to outperform expectations in space, structure, and production efficiency. While most Tesla vehicles stretch beyond the 4.6-meter mark, the Model 2 comes in at around 4,500 mm long, 1,790 mm wide, and 1,440 mm tall, making it about 230 mm shorter and 80 mm lower than the Model 3. Despite that smaller footprint, Tesla has managed to carve out nearly 20% more usable interior space, offering a combined cargo and cabin volume of around 2,450 liters. This impressive number is the result of precision packaging and a newly imagined roofline. The secret lies in the hatchback's fresh rear architecture. A steeply sloped C-pillar and a raised tailgate design provide a cargo bay of about 480 liters when the rear seats are folded, roughly 75 liters more than the Model 3. The flat load floor has been achieved by relocating the rear motor slightly forward and integrating the cooling modules beneath the subframe. This not only creates a deeper trunk floor but also improves aerodynamics by streamlining the rear underbody airflow. Even with only two doors, Tesla has optimized entry and exit with front openings that measure about 1.15 meters wide and use longer door hinges extending up to 37 degrees, similar to compact coupes like the BMW 2 Series. Inside, slimmer seats and a more compact dashboard design have freed up roughly 42 mm of extra knee room for rear passengers, making short city rides more comfortable than expected. When navigating tight urban streets, the Model 2's agility truly stands out. The new steering geometry gives it a turning circle of just 5.15 meters, even tighter than the Mazda MX-5 Miata's 5.3 meters. That means it can make U-turns on roads where most electric vehicles would struggle. Combined with a curb weight expected to stay under 1,450 kilograms, thanks to Tesla's massive 9,000-ton Gigapress single-piece rear casting, the Model 2 becomes not just nimble but also structurally advanced. Engineers report a 40% reduction in welding points and a 67% cut in assembly time, with manufacturing energy use down by about 30% compared to the Model 3's steel frame. Now, how can one LED strip save 25% more energy? Tesla's decision to replace the traditional dual headlights with a single, full-width LED light bar on the 2026 Model 2 marks one of the boldest exterior redesigns yet. Spanning 1,370 mm across the front, this unified lighting strip takes design inspiration from the Cybertruck's minimalist style. Beneath its sleek form, however, lies a serious engineering leap. According to early data shared by suppliers in Shanghai, the new monoline LED array operates at 9.8 volts instead of the standard 12 volts. It uses next-generation Osram Elon black flat chips, with each module producing around 1,800 lumens per watt. This setup allows the entire lighting system to draw just 92 watts under full beam, about 25% less than the 122 watts consumed by the Model 3 Highland's dual-beam setup. In real-world testing, that means roughly 4 to 5 additional miles of range over a 300-mile driving cycle. Durability also gets a major boost. Traditional headlamp assemblies use two separate housings, each with multiple boards, connectors, and cooling parts. Tesla's new light bar merges all of these into a single sealed aluminum housing with one printed circuit board and one high-voltage connector, reducing electrical joints from 46 to just 18. That simplification means fewer potential failure points, lower costs, around $85 saved per car, and a weight reduction of about 1.6 kilograms from the front end. Tesla's internal tests show a 12% improvement in beam distance, now reaching nearly 155 meters on high beam, aided by a new vacuum-sputtered reflective coating applied to the inner surface. This technology sharpens the beam focus without needing additional LEDs, giving the Model 2 stronger road illumination than the Model 3 Highland while also reducing glare for oncoming drivers. But how can Tesla really eliminate paint altogether? One of the most surprising innovations in the 2026 Tesla Model 2 is not something you see, it is what the car itself is made of. Tesla has developed an entirely new steel aluminum manganese alloy for the vehicle's body structure. The material balances strength, weight, and cost better than ever before. This alloy makes the Model 2's body around 8% lighter than the Model 3, about 45 kilograms less overall, while also being 15% stiffer. This stiffness means the frame bends less during cornering or impact. In fact, testing shows that structural flex has been reduced by about 20 Newton-meters per degree, giving the car a tighter, more confident feel on the road. But the truly groundbreaking part is Tesla's new finishing process, or more accurately, the lack of one. Engineers are testing a dry coat finish method that eliminates the need for traditional wet paint entirely. Instead of multiple primer, base, and clear coat layers that can cost up to $3,000 per car, the dry process uses a vapor-deposited protective film that fuses directly with the metal surface. This gives the alloy a natural satin look that resists scratches, oxidation, and ultraviolet fading. Since the color is built into the metal itself, there is no paint to peel, chip, or fade with time. If tests at Gigafactory Shanghai prove successful, the Model 2 could become Tesla's first truly unpainted mass-produced car. This would cut factory carbon emissions by roughly 40 kilograms of carbon dioxide per unit and simplify recycling at the end of its life. For buyers, it means a car that stays beautiful longer, requires less upkeep, and maintains its futuristic style for decades, all while being cleaner, lighter, and tougher to build. Now, how can new door handles and mirrors be one of Tesla's smartest improvements? At first glance, the 2026 model may look simple, but its door handles and mirrors have been re-engineered down to the smallest detail. The new horizontal pull-style handle replaces the older flush-mounted design, reducing the effort required to open it from around 30 newtons to just 18 newtons. In cold weather testing at -5 degrees Celsius, this updated mechanism maintained full function in 980 out of 1,000 test cycles. The older Model 3 handle, by contrast, showed freezing issues after just 170 cycles. Tesla also reduced internal components from 9 to 5 moving parts, cutting mechanical wear and shaving almost a minute off each door's service replacement time. The side mirrors follow a similar pattern of clever refinement. Their reflective surface area has been expanded from 35 to 39 square inches, offering about 4 extra inches of visibility width per side. This small tweak reduces the side blind spot to less than 1.9 degrees, narrower than any compact electric vehicle currently available in North America. The mirror housing itself has been reshaped to lower aerodynamic drag by 0.003 in the drag coefficient, adding about 5 miles of range on a full charge. Each mirror also features a dual-motor folding system linked to the car's rear radar, automatically retracting when it detects an obstacle closer than 30 centimeters. Finally, how can a $15,000 hatchback achieve Porsche-level aerodynamics? Tesla's new integrated rear body design brings the Model 2's drag coefficient down to an astonishing 0.22, the same as the Porsche Taycan, a vehicle that costs nearly 3 times as much to produce. Every reduction of 0.01 in drag coefficient typically adds around 8 to 10 kilometers of range at highway speeds. The Model 2's newly sculpted tail contributes significantly to this efficiency. A hidden rear spoiler molded directly into the tail section generates about 18 kilograms of downforce at 110 kilometers per hour, improving stability during crosswinds and lane changes. Tesla's internal data shows that lateral sway has been cut by nearly 7% compared to earlier prototypes without the integrated spoiler, resulting in more precise steering and smoother handling above 100 km per hour. Completing the aerodynamic package are Tesla's new 17-inch Aeroflow wheels. Each wheel features a closed-face design and an improved airflow pattern around the brakes. This reduces rotational drag by about 6 Nm compared to the Model 3's base wheels, increasing total energy efficiency by roughly 5.4%. In real-world driving, that translates to an extra 22 to 25 km of range per full charge, without making any changes to the battery itself. So, if you could pick just one feature to appear on your next Tesla, which one would you choose? Comment 1 for the new hatchback body, 2 for the LED light bar, 3 for the unpainted alloy shell, 4 for the upgraded handles and mirrors, or 5 for the aerodynamic tail and wheels. Let us know why in the comments below. If this breakdown helped you see Tesla's next big step more clearly, hit like, subscribe, and turn on notifications so you do not miss our next deep dive into the Model 2's powertrain and interior. You are watching Auto Intel, where real drivers talk Tesla with numbers that actually matter. Goodbye and see you in the next one. Music.